Hello, everyone, and welcome back. Today we're going to be talking about remainder theorem. Now, remainder theorem states that if a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. So in other words, all we need to do is find f of k, and we can know right away what the remainder is. Now, you might be wondering, well, why would this be useful when couldn't we just do long division or synthetic division and find the remainder that way? And yes, that is true. However, oftentimes remainder theorem in practice is used in order to figure out whether or not a certain polynomial is a factor of another polynomial, right? Or in other words, whether or not the remainder is zero. And so we probably don't want to do a whole bunch of long division questions just to finally figure out which one is going to have a remainder of zero. We would like to figure out in a more quick manner which polynomial does have that remainder of zero if we were to divide, and then just divide that one and save ourselves a lot of extra work. And so even though one may argue this theorem isn't completely necessary, it is certainly very useful in getting you where you need to get faster. Right? Because in this example here, they're not asking us to actually do the division. They're just asking us to find the remainder, right? And so we could do division in order to figure that out, but it would be much faster to just find out what f of negative 2 is and go from there. So that's what I'm going to do. F of negative 2 is equal to 3 times negative 2 cubed plus 2 times negative 2 squared minus negative 2 plus 5, which is equal to 3 times negative 8 plus 2 times 4 plus 2 plus 5, which is equal to negative 24 plus 8 plus 2 plus 5, which is equal to negative 24 plus 15, which is equal to, I think, negative 9. Yes, negative 9. And so therefore, the remainder is negative 9. And so therefore, x plus 2 is not a factor of 3x cubed plus 2x squared minus x plus 5. And yes, we could have figured that out by doing long division or synthetic division, but this was a lot faster. So this is a nice way to quickly figure it out. Okay, here's another question. It says, find the remainder when f of x is equal to 2x to the power 4 plus 6x cubed minus 5x squared plus 3x minus 1 is divided by x minus 4. So for this one, we need to find out what is f of 4, and that is going to be equal to the remainder. So we're going to have 2 times 4 to the power 4 plus 6 times 4 cubed minus 5 times 4 squared plus 3 times 4 minus 1. And let's see, what is 4 to the power 4? That's going to be a bit of a big number, 256. So 2 times 256 plus 6 times 64 minus 5 times 16 plus 12 minus 1. That's going to be 512 plus 6 times 64 is 384. Let's see, minus 5 times 16, which is 80, plus 12 minus 1. And let's see, 512 plus 384 plus 12 minus 80 minus 1 is going to give us 827. So therefore, the remainder is 827. And keep in mind here that because we're working with variables, right, because we're dividing by a linear, right, we're taking a larger polynomial, we're dividing by a linear, the remainder, as long as it's a constant, it could be however big or however small. Oftentimes we're used to having a limit on how big the remainder can be, and this is of course true when we're dividing by just regular numbers. In this case, when we have some variables in the mix, it can be it can be any constant, even though this is a very big constant. That's completely fine here. All right, well, that's remainder theorem. Feel free to ask any questions you might have in the comment section, and we'll see you for the next one.